हेलो स्टूडेंट्स, गुड आफ्टरनून। सो आज का लेक्चर बहुत इंटरेस्टिंग होने वाला है क्योंकि इन दिस लेक्चर आई एम गोइंग टू सॉल्व PYQ previous year's question that came in 2023 CBSE board, and topic is electric charge and field, electrostatic potential and capacitance. So without wasting our time, we'll start the video. My name is SR Prusti and you are watching my beautiful channel Love You Science. So let's start. Say, look at the question. The magnitude of electric field due to a point charge at a distance of 4 meter is 9 Newton per coulomb. From the same point charged object, the electric field is 16 Newton per coulomb will be at a distance of, there are 4 options, 1 meter, 3 meter, 2 meter and 6 meter. That question came in 2023 set number 1. So first of all, you should know the electric field due to a point charge at a distance will be equal to kq by r square, right? So here condition is there is a charge, point charge, let it be q with a distance of r, and here electric field is given 9 Newton per coulomb, right? Now the question is, what will be the distance from the same charge? What will be the distance from the same charge and electric field will be 16 Newton per coulomb. So there are two different cases, but charge is same. Let it is R1 and R2, and this one is E1 and E2. So electric field is kq by r square. In both the cases, q is constant, k is constant. So electric field is proportional to 1 by r square. That means we can write E1 by E2 will be equal to R2 by R1 whole square, right? So what is E1? E1 is given here 9 and E2 is given 16. It will be R2 by R1 whole square. So we can take under root of LHS and RHS, then we can get 3 upon 4 will be equal to R2 upon R1. What is R1? R1 is given here, how much? 4. So it is 4. So that means your answer is coming 3 meter. So option number B is correct. It is clear? It is very simple. You need to remember the electric field due to a point charge is kq by r square. There are two different cases. In two different cases, charge will be same and electric field is given 9 Newton per coulomb and 16 Newton per coulomb respectively. And one distance is given, you have to find out another distance. I hope it is clear. Okay. Look at the question. A point P lies at a distance x from the midpoint of an electric dipole on its axis. The potential at the point P is proportional to 1 by x square, 1 by x cube, 1 by x to the power 4, 1 by 1 root of x. That question came in 2023 set number 1. A question पहले क्या देखो, there is a dipole, you know dipole has two charges minus q and plus q, and here let P is a point which is x distance from the center of the dipole, and the angle between dipole movement, you know the direction of dipole movement is from minus to plus. The angle between the dipole movement and distance is theta. So you know the potential at this point will be kp cos theta by x square. Clear? Now the question is, what is the potential on the axial line? If I keep the point here, what is the angle? The angle will be how much? The angle will be 0. If theta is 0, cos theta will be 1. So V will be kp upon x square. So that means V is proportional to 1 by x square, option number A. Clear? ऐसे भी क्वेश्चन आ सकता है, what is the potential on the equatorial line? If it is coming, find the potential at the equatorial point. Equatorial point में theta कितना है? 90 degree. So that means if theta is 90 degree, cos 90 will be how much? 0. So potential will be 0. Clear? Okay. ये क्वेश्चन देखो, two charged conducting sphere of radius a and b are connected to each other by a wire. Find the ratio of electric field at their surface. That question came in 2023 set number 1. क्वेश्चन पहले देखो क्या है, देयर आर टू स्फीयर ऑफ रेडियस ए एंड बी and two charge sphere having charge q1 and q2. We'll have to find out the ratio of electric field at their surface. ये जो surface है, let electric field is E1, and here in the surface of second sphere electric field will be E2. So you have to find out the ratio of E1 and E2. One thing you remember, if you have a spherical charge sphere of radius r and charge q, the electric field at the surface will be equal to kq by r square. So what is E1? Tell me what is E1. E1 will be kq1 upon a square. And what is E2 here? E2 will be kq2 by b square. Is it clear? So what is E1 by E2? Here I am writing. What is E1 by E2? E1 by E2 kk will be cancelled. So it will be q1 by a square upon q2 by b square. So मतलब it will be q1 upon q2 into b by a whole square, right? So ये हो गया आपका आंसर. But you need to get the answer in terms of b and a. For that, what you'll do, if both the sphere are connected through a common wire, you will find a common potential V. The formula of common potential is C1 V1 plus C2 V2 by C1 plus C2. Okay, so this capacitance of the first sphere is C1 and second sphere is C2. You know this capacitance of a spherical capacitor is 4 pi epsilon naught r. मतलब capacitance is directly proportional to radius of sphere. So that means I can write down C1 by C2 will be equal to A upon B. Capacitance is directly proportional to radius. मतलब C1 is proportional to A and C2 is proportional to B. So C1 by C2 will be A by B. Clear? Again, you know Q is equal to CV. C is equal to Q by V. So मतलब in place of C1 I can write down Q1 by V. In place of C2 I can write down Q2 by V will be equal to A by B. VB will cancel. So मतलब Q1 by Q2 you are getting A by B. You put that value here. So मतलब Q1 by Q2 is A by B. ये क्या है B square upon A square. It will cancel. So your final answer will be E1 by E2 is equal to B by A. ये हो गया आपका final answer. ये बहुत easy question है, उतना difficult भी नहीं है. There are two spheres of radius A and B of charge Q1 and Q2 are given. If both are connected through a common wire, you will find a common potential. That common potential formula is C1 V1 plus C2 V2 by C1 plus C2. C1 capacitance of a spherical capacitor which is directly proportional to radius. So C1 is proportional to A, C2 is proportional to B. If I take C1 by C2 will be A by B. Again, you know C1 is Q1 by V, C2 is Q2 by V. V will cancel. So Q1 by Q2 will be equal to A by B. And you know electric field का formula क्या है? KQ by R square. मतलब E1 by E2 will be equal to this by this. Or you can say Q1 by Q2 into B by A whole square. So in place of Q1 by Q2 you put A by B. So B will cancel, A will cancel. So B by A is left. So E1 by E2 will be equal to B by A. ये हो गया आपका आंसर. Clear? I think it is done. ये क्वेश्चन देखो, a parallel plate capacitor A of capacitance C is charged by a battery to a potential difference V. The battery is disconnected and on charge capacitor B of capacitance 2C is connected across A. So find the ratio of final charge on A and B. So इसका मतलब क्या है? There are two capacitors having capacitance C and 2C. There are two capacitors A and B having capacitance C and 2C. So initially the capacitor A is being charged through a potential difference of V. Then that capacitor will be disconnected from the power supply and it is connected to another uncharged capacitor B having capacitance 2C. Then we have to find out the ratio of the final charge on Q1 and Q2. And second part क्या है? What is the ratio of total electrostatic energy stored in A and B finally and that stored in A initially. ठीक है, पहले देखो क्वेश्चन क्या है. A parallel plate capacitor A, right? So it is being charged through a potential difference of V. That capacitance is C1 and that is C. And the charge on the capacitor is, let it be Q. You know Q is equal to CV. ठीक है. Now the power supply will be disconnected from the capacitor C1 and another capacitor of capacitance 2C is connected. Matlab second condition will be your C1 is connected with another capacitor of capacitance C2 of value 2C, right? So what will happen if an uncharged capacitor is connected with the capacitor C1, then charge will flow till the potential becomes same. That potential is called common potential. Let this common potential is V. Let it be V dash. So both will have the common potential. Again I repeat, if a uncharged capacitor is connected with a charged capacitor, then charge will transfer from one capacitor to another capacitor till the potential becomes same. That potential is called common potential. इसका formula है C1 V1 plus C2 V2 by C1 plus C2. ठीक है? So now let final charge is Q1 of capacitor C1 and Q2 of capacitor C2. ठीक है? So now tell me what is Q1? Q1 is nothing but C1 into V dash. So that means C1 is C. V dash क्या है? इधर V dash. How do you find out V dash? V dash के लिए you know as per the charge conservation, initial charge will be equal to final charge. Initial charge कितना है? Q. Final charge कितना है? Q1 plus Q2. So मतलब initial charge will be equal to final charge. So Q क्या है इधर? C into V. But Q1 क्या है? What is Q1? C1 into V dash, which is C into V dash. And what is Q2? C2 into V dash. C2 कितना है? 2C into V dash, right? So in place of Q1 I can write C into V dash plus in place of Q2 it will be 2C into V dash. C will be cancelled. So matlab V is coming 3 V dash. So V dash is V upon 3. So what is the common potential we are getting here? V by 3. Is it clear? No doubt. Now the point is we have to find out the ratio between the charge on A and B. So now tell me what is Q1 by Q2? What is Q1 by Q2? Q1 कितना है? C into V dash. Q2 कितना है? 2C into V dash. So V dash will be cancelled. C will be cancelled. So Q1 Q2 is equal to 1 by 2. Is it clear? No doubt. We have to find out Q1 by Q2. Q1 कितना है? Q1 is C into V dash. Q2 कितना है? 2C into V dash. V dash will be cancelled. C cancel. Answer will be 1 by 2. I think it is clear. Second bit देखो. We have to find out the ratio between the electrostatic energy stored in A and B finally to that of energy stored in A initially. ठीक है? So initial क्या है? Capacitance was C and potential V was given. Then charge is Q. Tell me what is the initial energy of A of this capacitor? It will be half into CV square, or you can write down Q square by 2C. ये हो गया initial charge. Now the another uncharged capacitor 2C is connected to the initial capacitor C. Then what is the net capacitance? C effective is equal to C plus 2C. It is 3C. C effective will be equal to C plus 2C, that is 3C, right? And total charge is Q. So what is the final energy? So Q square upon C 2 into C effective. So final energy will be Q square upon 2. C effective कितना है? 3C. So it will be Q square upon 6C. ये हो गया total final energy. समझ में आ रहा है कि नहीं? दोनों का कैपेसिटेंस C1 and 2 C and 2C and total charge is Q, as I have told, because of charge conservation. Initial charge will be equal to final charge. और भी एक मेथड है, यू कैन राइट ये हो गया हाफ सी बी स्क्वायर, ये हाफ C1 V1 स्क्वायर, हाफ C2 V2 स्क्वायर, V1 V2 मतलब कॉमन पोटेंशियल ऐसे भी हो सकता है, बट द बेस्ट वे कि यू राइट दिस फॉर्मूला, एनर्जी का फॉर्मूला Q स्क्वायर बाई 2C. Initial energy is Q, capacitance is C, so final energy is how much? Q square upon 2C effective. C effective इधर 3C. Okay, total charge is Q. So what is the ratio? Final energy upon initial energy. Final energy मतलब total energy of the capacitor A and B, and EY का मतलब initial energy of the capacitor. So ये क्या है? Q square upon 6C upon Q square by 2C. C cancel, Q square cancel. So it is 1 by 6 into 2. So it is coming 1 by 3. So the answer is 1 by 3. Here, done. Solides. Look at the question. Using Gauss law, obtain an expression of electric field due to an infinite long thin straight wire with linear charge density lambda. That question came in 2023 set number 1. Question क्या है पहले देखो. Question is, we have a long straight infinite charged wire. We'll find out electric field at a point which is r distance from that wire. We'll find out electric field at this point. Here, and the linear charge density of that wire is lambda. So how to find out electric field at this point? So first thing, we'll have to make a Gaussian surface. Gaussian surface क्या होता है? It is a closed surface around the charged body. So here the nature of Gaussian surface will be cylindrical. So मतलब we'll have to take a Gaussian surface which is cylindrical in nature. So we'll find out electric field at this point. Okay. So let length of that cylinder is L. So in this cylindrical Gaussian surface, we have three surfaces. Two flat surface, let it be S1 and S2, one curved surface, that is S3. So we'll find out flux through each surface. That is our first objective. So you know flux through a surface is nothing but integration of E dot ds. E is the electric field, ds is the small surface area. So it will be integration of EDS cos of theta. Theta is the angle between electric field and normal to the surface area. Okay, so that thing you should remember. So flux through the surface 1 is, let it be phi 1. So we'll take a small surface area ds1, normal to the surface area is upward, and the direction of electric field is away from the charged body. The angle between E and ds1 is 90 degree. So what is flux phi 1 here? Phi 1 is E ds1 cos theta 1, मतलब integration of E ds1 cos theta. Theta is 90 degrees. So flux phi 1 is 0. Similarly, we can take another small surface area ds2, normal to the surface area is downward, direction of electric field is away from that where the angle is 90 degree here. So phi 2 क्या है? Integration of E ds2 cos theta. Since theta is 90 degree, flux phi 2 is 0. Third point is, to find out flux through the curved surface, we take a small surface of surface area ds3, and the normal to the surface area is outward, direction of electric field is also outward. The angle between electric field and ds3 is 0 degree. So flux phi 3 is what? Integration of EDS3 cos theta. Since theta is 0, cos 0 is 1, phi 3 will be equal to EDS3 integration. Since we'll find out electric field at this point, so E integration of ds3 is the constant. We'll find out electric field. So integration of ds3 is s3. So मतलब phi 3 कितना मिल रहा है? E s3 क्या है? What is the surface area of the curved surface? That is 2 pi r into L. R is the radius of the cylinder, L is the length. So surface area is 2 pi r L. So you put here, so 2 pi r L. ये हो गया आपका phi 3. So what is the net flux? Tell me, what is the net flux? Net flux is phi 1 plus phi 2 plus phi 3. Phi 1 तो 0 है, phi 2 क्या है? 0 है. So phi 3 कितना है? E into 2 pi r L. Let it be equation number 1. According to Gauss theorem, what is the net flux around that charge wire? It will be Q by epsilon naught. Net charge by epsilon naught. Let it be equation number 2. So from equation number 1 and 2, if you compare, you'll be getting E into 2 pi RL will be equal to Q by epsilon naught. So implies E will be Q by 2 pi R epsilon naught into L. So Q by L क्या है? Linear charge density. Charge upon length is linear charge density, which is lambda. So your final answer will be lambda by 2 pi R epsilon naught. Okay, so that much you need to write. ये question बहुत important question है. I hope it is clear. No doubt. Shall I erase it? Look at the question. An infinitely long positively charged straight wire has linear charge density of lambda. An electron is revolving in a circle with constant speed v such that the wire passes through the center and is perpendicular to the plane of the circle. Find the kinetic energy of the electron in terms of its magnitude of charge and linear charge density lambda. Also, we'll plot the graph between kinetic energy and lambda. So पहले देखो ये क्वेश्चन दैट क्वेश्चन केम इन 2023 क्वेश्चन नंबर 31 बिट बी बिट सी. तो पहले देखो क्वेश्चन क्या है. वन इनफाइनाइट लॉन्ग स्ट्रेट वायर इज गिवन. ओके, वी नो at a certain distance the formula of electric field due to that long straight wire is lambda upon 2 pi r epsilon naught. lambda क्या है? चार्ज upon length. ठीक है. now one if a electron revolves with a constant speed, then that electron experiences a electrostatic force due to this field. What is that electrostatic force? You know, Q into E. Q क्या है? चार्ज, और you can say electron. E क्या है? lambda upon 2 pi r epsilon naught. Let it be equation number 1. So now a centripetal force will be developed due to that electrostatic force, or you can say the electrostatic force. A electrostatic force will produce a centripetal force, right? So centripetal force क्या है? mv square upon r. This is equation number 2. Again I repeat, first we will find out electric field at a point r distance from that long straight wire. That electric field is lambda upon 2 pi r epsilon naught. If a electron revolves with a constant speed, that electron will experience a electrostatic force which is Q into E, that is E into lambda upon 2 pi r epsilon naught. That electrostatic force provides the centripetal force since it since it revolves with a constant speed of v. So electrostatic force will be balanced by the centripetal force. We can write down from equation number 1 and 2 E lambda upon 2 pi r epsilon naught is mv square upon r. R will be cancelled. So we can write down mv square is equal to E lambda upon 2 pi epsilon naught. Clear? But we need to find out kinetic energy. Kinetic energy का formula क्या होता है? What is kinetic energy? Kinetic energy is half into mv square. So it will be half into mv square क्या है? E lambda upon 2 pi epsilon naught. Clear? So we can write down it will be 1 by 4 pi epsilon naught into E lambda. 1 by 4 pi epsilon naught क्या है? K, electrostatic force constant. So it is K into E into lambda. ये हो गया आपका आंसर. So the formula of kinetic energy is K, electrostatic force constant, into E into lambda. Done? I think it is clear. So that means we are getting the answer kinetic energy of the electron in terms of its magnitude and linear charge density lambda. Now the point is we will have to draw the graph between kinetic energy and lambda. देखो electrostatic force तो constant है, charge on electron is constant, so we can say kinetic energy is directly proportional to lambda. So if we plot a graph, you take lambda in x-axis and kinetic energy in y-axis. So the graph will be straight line. The graph will be straight line. Then I think it is clear. No doubt. Shall I erase? See the question. Consider two identical point charges located at a point 0, 0 and A0. Is there a point on which the line joining them at which electric field intensity becomes 0? Second bit is there a point on the line joining them at which potential becomes 0? पहले first bit देखते हैं. क्या क्वेश्चन है? देयर आर 2 point charges and both are identical. Let it be q and q, and the coordinates are 0 0 and a0. So that means the separation between the two charges a, and both the charges lies on x-axis. Question is there a point on the line joining them at which electric field intensity will be 0? Since both are positive charges, we can take a point at the middle of the line, which is a by 2 distance from each charge. So in this point, the electric field due to this charge will be balanced by or cancelled by electric field due to this charge. See, let it be 1 and 2. So here E1 क्या है? E1 मतलब इलेक्ट्रिक फील्ड एट दिस पॉइंट ड्यू टू फर्स्ट चार्ज, इट विल बी KQ बाय A by 2 स्क्वायर. इलेक्ट्रिक फील्ड का फॉर्मूला क्या होता है? KQ बाय डिस्टेंस स्क्वायर. सो इसका नेचर क्या होगा? आउटवर्ड, अवे फ्रॉम द चार्ज. Similarly, we will find out electric field at this point due to this second charge. It will be KQ by how much? Again A by 2 square. And what is the direction? Direction is away from the charge. So what you conclude from here? The magnitude of E1 and E2 will be same and direction opposite. What is the net electric field? It will be 0. That means E1 minus E2. Answer will be 0. अरे दोनों का मैग्नीट्यूड सेम है, डायरेक्शन अपोजिट है. व्हाट इज द नेट इलेक्ट्रिक फील्ड? इट विल बी 0. So that means answer is S, and the point is A by 2 from any of the charge. Now the point is second bit. Is there a point in the line joining them at which potential becomes 0? No. The answer is no. Kyun? Because potential is a scalar quantity. Since both are positive charge, obviously we will be getting potential will be positive. We cannot get 0. पोटेंशियल का फॉर्मूला क्या होता है? KQ by distance. Okay, so we can take any point on the line. We'll be getting what? K into Q by distance. Let it be A by 2. And for the second point charge, it will be again KQ by A by 2. अगर हम लोग बीच में लेंगे, or else if we take at any point on the line, we will be getting a positive answer. We cannot get 0 answer since it is a scalar quantity. Is it clear? अगर ये एक पॉजिटिव होगा एक नेगेटिव होगा, देन वी कैन गेट 0 पोटेंशियल. क्यों? देखो पोटेंशियल का फॉर्मूला क्या है? KQ बाय डिस्टेंस. KQ बाय डिस्टेंस, इट इज अ स्केलर क्वांटिटी. सो यहाँ पे पोटेंशियल क्या हो जाएगा? V1 प्लस V2. V1 क्या है? पोटेंशियल ड्यू टू प्लस क्यू चार्ज. V2 क्या है? पोटेंशियल ड्यू टू माइनस क्यू चार्ज. सो ये क्या हो जाएगा? KQ बाय A by 2 प्लस K into minus Q by A by 2. Since potential is scalar quantity, प्लस होगा तो प्लस लेना है, माइनस होगा तो माइनस लेना है, तो इट विल बी कैंसल, आंसर विल बी 0. से मतलब एक प्लस अगर होगा और एक माइनस होगा, देन वी कैन गेट पोटेंशियल एट दिस पॉइंट विल बी 0. लेकिन इलेक्ट्रिक फील्ड यहाँ जीरो नहीं होगा. क्यों? सी, ये पॉइंट में इलेक्ट्रिक फील्ड E1 क्या होगा? KQ by A by 2 square. What is the direction? Away from the charge. But due to negative charge, electric field क्या है? फॉर्मूला KQ by A by 2 whole square. What is the direction? Towards the negative charge. What is the net electric field? E1 plus E2. So you cannot get 0 answer here. I think it is clear. Okay, shall I erase? देखो ये क्वेश्चन क्या है? There are 3 different charges. One is plus 4 microcoulomb, minus 4 microcoulomb, and plus 2 microcoulomb are located at 3 corner ABC of a equilateral triangle of side 2 meter. So we'll have to find out what is the net potential energy. We'll have to find what is the net electrostatic potential energy. Okay, so electrostatic potential energy क्या होता है? Between two charges is K Q1 Q2 by distance. And electrostatic potential energy is a scalar quantity. प्लस होगा तो प्लस लेना है, माइनस होगा तो माइनस लेना है. मतलब if there are two charges are kept with a separation R, we can say potential energy is K Q1 Q2 by R. Is it clear? Is it clear? Okay. Now, so we'll find out the potential energy of the entire system. Let this one is Q1 and this one is Q2 and this part is Q3. So we'll be getting three potential energy. So one is U12 plus another is U23, third is U31. So what is net potential energy? Potential energy between 1 and 2, 2 and 3, and 3 and 1. So what is U12? Tell me, what is U12? K into Q1, Q2 by distance. Distance is how much? 2 meter. And what is U23? Potential energy between 2 and 3. Again it is K, Q2, Q3 by how much? 2 meter. And the potential energy between 3 and 1. It is K, Q3, Q1 upon again 2, distance is 2. So that means if we add these 3, we can take K by 2 as common. So answer is Q1, Q2 plus Q2, Q3 plus Q3, Q1. Then we can put that value. So K is 9 into 10 to the power 9 by 2. Q1 कितना है 4, 4 into 10 to the power minus 6. Q2 कितना है -4. So it is -4 into 10 to the power minus 6 plus. What is Q2? -4 into 10 to the power minus 6. Q3 कितना है 2 into 10 to the power minus 6 plus. What is Q3? Q3 is given 2 into 10 to the power minus 6 into Q1 कितना है 4 into 10 to the power minus 6, right? So you can take 10 to the power minus 6 as common, then you can solve it. So 9 into 10 to the power 9 into 10 to the power minus 6, you take common. So it is 4 into minus 4 minus 16 plus it is coming minus 8 and 4 2, it is plus 8. So it is cancelled. So answer is minus 8. So answer is minus 72 into 10 to the power 3 जूल. ये हो गया आपका टोटल पोटेंशियल एनर्जी. ठीक है, आई थिंक इट इज क्लियर. Shall I erase? So with this I am ending this lecture. Hope you guys understood what I have explained. Thank you so much for watching my video. Thank you.